Hello student and welcome to the course Urban Rail Transit Tracks, Stations and Yards. In this part, we're going to study everything about rail. And in this lesson, you will learn different types of rails and their features. Rails are members of a track laid in two parallel lines to provide an unchanging, continuous, and level service for the movement of trains. To be able to withstand stresses, they are now made of high-carbon steel. In fact, the rail as supporting and guiding elements was first utilized in the 16th century. In those times and mines in England used wooden railways to reduce the resistance of the mining vehicles. The running surface was provided with an uprighting edge in order to keep the vehicles on the track. Amid a crisis stemming from excessive iron industry production in England in 1760, a solution emerged. Wooden rails were outfitted with cast iron plates, resulting in a significant reduction in running resistance. Vehicles were moved forward by manpower or by horses. The rail stands as a paramount element with the track structure, embodying the multifaceted rail encompassing several vital functions. Firstly, it establishes an unbroken level platform essential for the seamless movement of the train. Additionally, the rail assumes the responsibility of guiding the train's wheels laterally, proficiently, managing horizontal transverse force that are effectively dispersed across sleepers and supports. At the same time, in contrast to the friction between the rubber tire and paved road, the rail produces an exceptionally smooth track because of the minimal friction between the steel wheel and the steel rail. Beyond its mechanical attributes, the rail serves an adept electrical conductor in the electrified lines, facilitating the transmission of currents. Furthermore, this indomitable concept adeptly shoulders the burdens arising from vertical loads, expertly navigating stresses channeled through axles and rolling stock wheels, including the complexities of braking and thermal forces. In sum, the rail embodies an intricate symphony of functions that underpin the intricate ballet of railway operations. Because rails support and guide the wheels of the train vehicles, their profile has been an object of continuous improvement since the appearance of railways. Here are some types of profiles. The first rails widely used in the 19th century were double-headed, being developed by Robert L. Stevens, an American civil engineer and inventor. They were crafted from wrought iron and varied lengths ranging from 610 centimeters to 732 centimeters, marking a significant chapter in the evolution of rail technology. Double-headed rails are made in the shape of capital letter I or dumbbell section, featuring a composition consisting of three distinct components: an upper table, a web, and a lower table. The idea was once a head wore out during service, the rail could be inverted and reused. Experience, however, showed that while in service, the bottom table of the rail was dented to such an extent because of long continuous contact with the chair that was not possible to reuse it. That's why the double-headed rail was almost abandoned in many countries at the beginning of the 20th century, although it is still in use in some railways and metros in the United Kingdom and elsewhere. The problems with using double-headed rail led to the creation of different kinds of called bull-headed rail. This new rail design, invented by Benjamin Outram, an English civil engineer and industrialist, had a similar shape but was stronger, with more mantle in the top part to withstand damage better. The bull-headed rail is made of tough steel and has a larger top part compared to the bottom. The bottom part is important for keeping the rail in place using wooden pieces called keys. This type of rail became quite popular in England and had specific weight standards for different types of rail lines. Main lines has heavier rails weighing 47 kilograms per meter. while branch line had slightly lighter ones weighing 42 kilograms per meter. The rails were typically about 18.29 meters long, which helped make the rail systems work efficiently. However, the bull-headed rail had some downsides. Because of the shape flat on top and rounded on the sides, it didn't have a lot of contact with the train wheels. This caused a lot of pressure and wear on the wheel edges and the rail top part, making them wear out faster. This also meant frequent repairs were needed. Another issue was that the ride on these rails could be a bit bumpy for trains because the transition between the wheel and the rail wasn't very smooth. Because of these problems, many rail systems have started using newer rail designs that are more durable and offer smoother ride. A flat-footed rail, also called Vignau's rail, that is named after British engineer Charles Black Vignau, who designed it. With a cross-section like Chinese calculator gong, the rail could be fixed directly to the sleepers with the help of spikes. The flat-footed rail has been standardized for the wide adoption around the world, where 90% of the railway track is made up of this type of rails. The utilization of flat-footed rails presents a range of advantages that underscore their favorable characteristics. Notably, the absence of the chair requirements simplifies their installation, with the rail space directly secure the sleeper through the spiking or keying. This design also imparts increased stiffness. It can handle bending and twisting better than bull-headed rails of the same weight, especially in the curves of a track. Additionally, flat-footed rails exhibit enhanced resistance to kinks, ensuring their consistently smooth top surface, setting them apart from bull-head rail. In terms of cost effectiveness, they emerge as a more economical option compared to the bull-head rail. Moreover, their unique load distribution mechanism effectively spread loads across a larger area, thereby fostering exceptional track stability, prolong the lifespan of both rails and sleepers, curbing maintenance expenses, mitigating rail failures, and minimizing traffic disruptions. When we look at how the flat-bottom rail works, we can break it down into three main parts: rail head, rail web, and rail foot. Starting with the rail head, it's carefully designed to make sure that it connects well with the rail tread, making sure everything works smoothly. This involves making a certain size to handle a lot of wear and tear over time. Next, the rail web's thickness is decided based on how strong it needs to be to resist bending and buckling even if it gets rusty. For rails that have joints, holes are made in the webs so they can connect it together using special pieces. Finally, the rail foot is the bottom part and is made wider to keep the rail stable, spread out the weight on the sleepers evenly, and make sure it's strong enough to stay steady from side to side. The rail foot also serves to fasten the rail directly or indirectly to the sleeper. When replacing the rail with another profile, it must not be forgotten that different foot widths cannot always simply accommodated by the existing fastening. Apart from the former three types of rails, the grooved rail is in use along tracks where the rail top and the pavement surface are at the same level. The grooved rail was invented in 1852 by Alphonse Loubat, the French inventor who developed the improvements in the tram and the rail equipment and helped develop tram lines in New York City and Paris. The invention of grooved rail allowed tramways to be built without bothering other people using the road, except for cyclists who might accidentally get their wheels stuck in the groove. In summary, double-headed rail is symmetrical with two raised heads, used early but wore out quickly. Bull-headed rail is similar to double-headed but stronger due to large head, popular in England, better weight resistance. Flat-footed rail has a flat base for stability, easier to install, common in modern systems. Grooved rail features a groove on the railhead used in the tram or light rail system for secure placement and smooth movement. In the next lesson, we'll delve into the fascinating world of rail manufacturing. We're going to explore the intricate processes and techniques involved in creating various types of rails. Understanding the manufacturing aspect of a rail system will provide valuable insights into the foundations of these essential transportation networks. See you next time.